Hello everyone. We're going to start our last unit in statistics. There's really just two main problems, but they're long in each case. You will need a calculator for both of them, so make sure you email me or whatever and try to get plans to try to get a calculator or borrow a friend's or something if you need to. The idea of this first type of problem is we're going to do packet A26. It's called correlation and regression with predictions. The idea is going to be if we have two things, we want to know, is there a relationship between them? If there is, then we want to go ahead and make an equation that's called a regression equation. And then we may ask to do a scatter plot, find a line of best fit, all this other stuff. So, in a nutshell, what's going to happen is I'm going to give you data points. So, as a quick, just like overview of what's going to happen, is I'm going to say, okay, the height of a person is 68 inches, 72, 70, 67, and 71. Then their shoe sizes are 9, 12, 11, 8.5, and 10. I'm going to assume there's no relationship between height and shoe sizes because you just can't assume things. So we're going to have our null hypothesis be that P equals 0, which I'll show you an example of this exactly, but we're going to assume there's no relationship between them. And then we're going to try to prove there is a relationship between them. So in this case, if you look, most of you probably know the taller a person is, usually the bigger the shoe size. But we have to statistically prove it. So we're going to go through a process of doing this. So what we're going to do is we're going to find a critical value, just like we would with z values or t values. We're going to find it. We're going to use table I, which I'll go over all that when we go through an example. And then what we're going to do is we're going to take this data and we're going to put it in our calculator. You're going to hit stat edit, and for L1 you're going to put your x values, your independent variable, and then in L2 you're going to put your y values, which are going to end up being your dependent variable. So anyway, you put these in L1, these in L2. You go stat edit, and then that's how you enter your data. So then what you're going to do is you're going to go stat, you're going to arrow to math, and you're going to go to two variable stats. And if you go to two variable stats and hit enter, all these things are going to pop up. E to the x, e to the x squared, e to the y, e to the xy, e to the y squared. And you're going to get all these data things. And then we're going to use those, and I'm going to show you in the example of exactly how we're going to use them. We're going to put them in a formula, and we're going to find what's called my correlation coefficient, which is R. I'm going to compare this to my critical value that I'm going to find, and if R happens to be to the right of my critical value or to the left, if it's a negative correlation, then it's going to be enough to say, hey, I have enough evidence to say there's a relationship between the two. So let's talk real quick about positive and negative. With height and shoe size, obviously the taller a person is, the bigger their shoe size. Okay, it's a positive relationship between the two. A negative relationship would kind of be age and how many hours people work out a week. You know, the older you get, what happens is you start really working out less and less. So that would be a decrease. You could talk about it with slope of a line. So, like I said, we're going to be given values. You're going to put them in your calculator. You're going to go to two variable. You're going to get all this information. You're going to put them in a formula I'm going to give you. And then you're going to get a correlation coefficient. You're going to compare it to the critical value, and for us, they're always going to be that there's enough information to assume that there's, a relationship between the two. So then I'm going to ask you to do two other things, actually three, but two of them are kind of related. The first is to do a scatter plot. A scatter plot looks like this, and all I want you to do is to take your x's and just make a good scale. It goes from 68 to 72. I went by 2's here. I should have went by 1's, but because I have a small board, I had to do this. For shoe sizes, I just went from 8 to 12. All you have to do a scattergram is make sure your axes are good, have a good scale, and you just plot the points. So you go 68, 9, you go 72, 12, you go 70, 11, you go 67, 8.5, and you go 71, 10. Now, I only gave you 5 data points, but as you can see, as I move to the right, I go up. So the next thing we're going to do is we're going to find what's called a line of best fit. Now, I know a lot of us in pre-calculus, I showed you how to do that in your Algebra 2 teachers. You'd go to stat, go to math, and then you go down, and there's 2 linear regressions. The first one is algebraic. The second one is statistics, like this. If you do that, it gives you what these 2 things are. However, I don't want you to take that shortcut only to check your work. I'm going to give you formulas of how to do these, and I'm going to tell you I want to see a numerator and a denominator to make sure you're doing all this. And then what happens is you're going to get some type of line of best fit. So it may be something like 8 plus, and then 0.5x, something like this. So then what you can do is you can estimate. So if I said, hey, somebody is whatever height, you can plug it in here and find out their shoe size or whatever. This is probably like 0.05 or something. I don't know, I just made that up. I don't know what it is. But then what we do is we can estimate. So if I give you the height and ask you to find the shoe size, you just plug right in here for x and solve. If I ask you to find the height, if I give you the shoe size, you plug in here and solve for x. And that's what I want you to do. And the last thing they're going to do is say, estimate using a graph. So I said, okay, what if somebody was 69 inches tall? Well, you'd come up here and you'd say, oh, they probably have about a 9.5 shoe size. So you can estimate by using the graph too. And the last thing I want you to do is to take this line and actually plot it on there. Now, the way I want you to do that is very simple. I want you to pick 2 x values and plug it in. So pick something like, preferably not any of those exact values. So in this, let's just do 66, and then in this case, I would do 73 to go on the outsides. And you're going to see that this will be like a 7.5, and this one would be like a 12.5. Then actually plot those 2 points and draw a line between them. And that is kind of like the line of best fit. Okay? Your homework is going to be page 559, 12 through 5 and 20 or 15 and 23. I want you to show all steps. So page 559, 15 and 23, I want you to show all steps. So now I'm going to bring this over here so we can kind of see what's happening here. Okay, so this is the type of problem. So I'm just going to walk you through this. You're going to identify the claim to be. So there is a significant relationship between height and shoe size. P sub 0, or H sub 0 is your null hypothesis. We're always going to say P equals 0. This says that there is no relationship between the two. My alternative hypothesis, which is my claim, is that P is not 0, meaning there is a relationship between the two. So on page 793 is table I, and this is how you're going to find this, okay? So right now we're going to use a tail of 0.05. Your degrees of freedom, because I have 2 variables, are going to end up being n minus 2. So table I is on page 793, okay? And so what we do is we use this column here. Now in this case, I had 5 points, so I would come here and I would take 5 minus 2 is 3, and I would use 8.78 and negative 8.78 to mean my critical values. So like I said, after that, what you're going to do is, so you put your critical values here and here. You're going to go to your stat, you're going to enter your data points, and these are all the things you're going to find. Okay, they'll tell you what these are. And then once they find out what these things are, you're going to use R, and you're going to use this formula. And no, you won't have to memorize it. What I want you to do is plug everything in the numerator and get that first. I want you to use this part of the denominator by itself and this one. I want to see these 3 numbers whenever you go to do this. And the reason why is when we go to find the line of best fit, we're going to use these numbers individually, at least a few of them. Okay? So after that, I'm just going to go straight to an example so you can kind of see well, let me go ahead and go over this first. Once we find the line of best fit, these are going to be the 2 formulas. You're going to see them on a sheet of paper that you can just copy off. So that's why we need to use the value of the first bracket in the denominator, which is this guy right here. So we're going to use this one here on the bottom of those. And the value of the numerator is going to go here. And then we use some of the other ones that we used on there. And then this is going to end up giving me my slope and my y-intercept. So let's get to an example so you can see what I'm talking about. So now we're going to say, a researcher's determined there's a significant relationship between a person's age and the number of hours that they exercise per week. Test the relationship with a tail of 0.05. So if we look, here I have one person, 2, 3, 4, 5, 6, 7. So a 15-year-old works out 6 hours, 18, 10, and blah, blah, blah. As you can see, the older that they ask, the less hours. But we have to assume there is no relationship. So my claim is that there's going to be a significant relationship between a person's age and the hours they exercise. We're always going to assume there's a zero relationship, and we're going to try to prove that it's not equal to zero. So what you do is you need to find your critical values first. So I have 7 people, because I have 1, 2, 3, 4, 5, 6, 7. So my degrees of freedom is 5. So I go to table I, and I go to 5, and I slide over, and I get 0.754. So that's going to be my critical value. So I have negative 0.754 and 0.754. So now I need to find my test value, which is R, my correlation coefficient. So I put all these in L1, I put all these in L2, and I go to stat, I go to math, and I go to 2 variable stats. When this pops up, it'll say the N is 7, the sum of X is 220, the sum of X squared is 7858, this is 37, 247, and 993. So then what I do is I go and I use these and I put them in my formula. So if you go back to this, when I put those numbers in my numerator, this is what I get. Then that's my first thing in my denominator, and that's my second. So I want to see these 3 numbers. Then when you type all this in, this ends up being my correlation coefficient. So it's negative 0.771. The negative tells me that the relationship is negative, meaning as X goes up, Y goes down. We kind of assume that because the older you get, the less you work out. So when I go and I compare it to my critical value, I'm in this range. Well, if I know I'm over here, that means I have enough information. So my decision is to reject my null hypothesis. And based on the sample, there is a significant relationship between a person's age and the number of hours they work out. If you want to put negative in there, that's fine. So then what I want you to do next is I want you to take this and I want you to make a scatter plot. So on bottom, I just went from 10 to 50 by 5s. And here I went from 1 to 10. And then you just start putting in the X's. Make sure you label the axes. So 15, 6. Then I went 18, 10, and I just kept putting them on there. So that's my scatter plot. So then in order to find A and B, even though I just wrote them down there, I want you to use the formula that was on this page right here. So if we use those formulas to find A and B, this is what you would get. Now, in order to find a regression line, which I didn't put this on here yet, but what I would do is I would pick 10 and 50. If you plug 10 in here, you're going to get a number somewhere up here. Then if you plug 50 in, so plug 50 in here, you're going to get a number like down here. So what I would do is I would just put the little dots there, and then what you do is you just draw a line between it, and that's going to be your line of best fit. So when they say draw the regression line, that's what I want to see. So then finally, you're going to be asked questions to use this. They're going to say, hey, using the graph, predict the number a 22-year-old. Well, if you want, you can just kind of slide over here to 22 and just say, hey, it's about 7. So you can use the graph to predict this. The next question, which it's if you do it on a calculator, is 6.982. Then it says predict the age of a person who works out 2 hours a week. Well, 2 hours a week means you're over here, you're about 45 years old. So you can use this graph to predict one or the other if I give you the other variable. And then the last one, it says use the linear regression. So when it says to predict a 35-year-old, what I want you to go in here, I want you to put 35 right here and actually take 35 times negative 0.180, add this to it, and that is going to be your answer. Okay? And then for the last one, 3.5 hours a week, you want to predict the age. Well, you put 3.5 in here. Subtract this over, divide, and that'll tell you the age of someone who works out 3.5. Okay, so 559, 15, and 23 show all the steps. The packets are in here. Real quickly, I'll show you, just give you a quick look. That's number 26, so those are the answers you should get. that's going to end up being 23, the front part of 23. That's the back part of 15, the back part of 15. Then that should be what you get for 23's answers and 23's answers. Okay, good luck, and if you have any questions, feel free to email me. Thank you.